All right, today we're going to go over something that we did in class, but I wanted you to see another example, and you probably didn't finish the one in class anyway. So what we're going to do is look at correlation, regression, getting an equation on your calculator, lots of neat stuff, all right? Now you can see all of those here. We're going to work through each of those one by one and talk about what each of those means. I've just kind of made little notes here, but on a celebration or quiz, of course, you would have actual questions. You know, it would be a little bit more specific what it's looking for. All right, so first we go for correlation type. Okay, well, looking at this, it's going down, which means it's a negative correlation. And it looks pretty close, you know, you can definitely tell that that's going straight down, that it's linear. So I would say it's a strong negative correlation. All right, now if we estimate R, okay, go ahead and give it a try. It's definitely strong, which means it's strong is between 0.75 and 1. It's not perfect, so it's definitely not 1. It's pretty good. I'd guess probably somewhere between 0.9 and 0.95. So I'm going to go 0.9, and I'm going to put a little squiggly equal sign showing that it's approximate. I'm just kind of guessing. All right, let's go on to the next one, mean point. Mean point doesn't mean that it's an angry point. This point is angry. Let's see, he needs some teeth. That doesn't really look like teeth, does it? Okay, but he's angry. That's our mean point. No, mean point is the average point, which means we need to average the x values and the y values. Now, since we don't have those, then what we need to do is actually find them. So what I'm going to do is I'm going to create a table here for x and y, and since it's on the graph, the best thing I can do is just kind of guess. Okay, so here in 99, and I'm actually going to change this. I'm going to make the x-axis years since 1999. Okay, just because with these numbers going from 99 to 0, that's going to play havoc with my data, because it's not really 99. It's 1999, and then 2000, and then 2001. You could do that if you wanted. You could put the full year down, but don't put the 99 and 00. I'm going to do years since 99, which will make this 0, 1, 2, 3, 4, 5, 6. If you want, you could do something else that would work. Like I say, you can put the whole year in if you want, but I'm just going to do it this way. So I'm going to put x 0, and then y is, you're just going to have to guess, like 935 or something. Okay, the next point would be 1, comma, that's a little bit closer to 950, maybe 945. So 1, 945. And you go ahead and do that. I'm going to pause it and fill in the rest of the data. There we go. We got our table filled out. So now to find the mean point, I'm just going to average all the x values and average all the y values. So x bar, that's the average x value. We talked about that last class. I'm going to go ahead and bring up my calculator, and I'm going to go 0 plus 1. Now there's another way to do this, but we'll do it this way first. Plus 5 plus 6. Okay, and then there are 1, 2, 3, 4, 5, 6, 7 numbers, so we divide by 7. And you probably could have figured this out just by looking at it, but the mean is going to be 3. And then we're going to do y bar as well. And so we're going to go 935 plus 945. This calculator is going to be the death of me. Plus 880. Hold on. Okay, so I just typed them in. Everything's there all the way up to the 705. Push enter. Get the sum. Divide by how many there are. There are 7. Now, we expect it to be somewhere between 935 and 705, right? So somewhere in the 800s, or maybe high 700s. It ends up being 825. But that's just kind of a check. If you get a number that's weird, then you probably typed something in wrong. Okay, so then we got our mean values, which means that at 3, 825, that's our mean point. So I'm going to go ahead and do that one in blue. So we put the mean point right there. And with our mean point, we can now draw a line of best fit. And actually, I'm going to draw one with arrows on it. So something like this. Okay. Now I'm going to take this and maybe move it around just a little bit. All right. let's see, that looks pretty good actually. Goes through my mean point. You'll notice that as we look at it, there's 1, 2, 3, 4 points above, there's 1, 2, 3 points below, but the points above are a little bit closer. You've got points above and below there, you got points above and below here, so that's probably going to be a fairly good line of best fit. Alright, so we got our mean point. The mean point is 3,825, and then we need an equation by hand, and so for the equation by hand, we're going to use y minus y1 equals m times x minus x1, just like that. And so we'll go ahead and we need a slope. So to get the slope, you can take 2 points from your line. Really doesn't matter which points you use, but I'm going to use the mean point, which is 3,825, and I'm going to use this point right here because it looks like it crosses right there at 7,650. It doesn't matter that it's not on the graph. In fact, the points don't need to be on the line. You don't need any points on this line except for your mean point. Your mean point should be on your line. But when you do your slope, it doesn't need to be any of your real points. It just needs to be points on the line. So as long as you do that, you should be fine. And so we'll go ahead and we'll find the slope. So I'm going to use 3,825 and 7,650. And so I'll go 825 minus 650. You remember this. y2 minus y1 over x2 minus x1 is the slope. And so we'll do that. y2 minus y1 over x2 minus x1. And when I do that, I should get negative 175 over negative 4, which I guess I could do that in my head, but you probably wouldn't believe me. So I go 175 divided by 4. Negative by, actually that should not be negative, that should be a positive right there. So a positive divided by a negative will give us a negative answer, which will be 43.75. So I can put that now in my equation. And so I'm going to go y minus y1, which the point that I'm going to use is going to be my mean point. That's the only point that I know absolutely for certain is on my graph. So minus 825 equals the slope, so negative 43.75 times x minus x1. Okay, there you go. You got an equation by hand. The next thing that we're going to do is do an equation by calculator. So calculate away, and what we're going to do is the first thing we got to do is we got to put our points in there. All right. Now you may remember when we did the one variable statistics, we went into stat, and it gave us a whole bunch of columns. So we're going to go into stat, and we're going to edit, and this time we're going to put in 2 columns of data. Okay. Now I'm going to clear these out. You don't really need to clear them out actually, because we're just going to type over them, but you know, just because we can. So we'll go ahead and we'll put the numbers in here. I'm going to pause it and just put the numbers in. So all my numbers are in. So I'm going to go quit now. That's in blue here. So blue button quit. So now I'm going to go into the stat again, and this time I'm going to calculate. Now you could do a couple of things. One thing I want to show you real quick is you could do the 2 variable statistics. Now if you do the 2 variable statistics and push enter, if it comes up with the other stuff, just make sure that the first data is in L1 and then the next one is in L2, and then you've got L3 of course from there, which you won't need because you don't have a frequency list. So it'll just be L1 and L2 is where your data will be. And then from here we got the 2 variable statistics. It's going to give us a whole bunch of information. Note right here that it gives us the average x, which is 3. And then a bunch of other stuff. It showed that there's 7 of them. And here's the average y, which was 825.71, which I guess I probably should have put that as 826, but you know, it doesn't really matter. So you've got your 2 averages right there. And you can see all the other information, some of the x's, some of the y's, the standard deviation of each one. It's got your minimum x, maximum x. So it's got all that information for you there. That's not actually what we're after right now. We're going to go into stat, calculate, and we want it to create an equation for us. And the way that we do that is by doing the linear regression. So we're going to go down here to linreg, push enter. And when you push enter, it may have some other stuff. You want it to take it from list 1 and list 2. just based off of what operating system you have on your TI-84. Just make sure that it does list 1 and list 2, and then you push enter or calculate or whatever, and you'll note that right here you got a couple of things. Number one, it gives you y equals ax plus b, and then it gives you a and b. So it says that a is negative 42.3. So I can just copy this equation down, and so I'm going to go y equals negative 42.3. Okay, that was this one right here. X plus b, and b is about 953. Okay, now I don't know if you realize this, but if you took our equation right here, right, and we distributed the negative 43.75, you'd have y minus 825 equals negative 43.75 x plus, and then 3 times 43.75 is 131.25, and then add the 825 on there, which would be 956. So that's y equals negative 43.75 x plus, what was it, 956? Oh man, we were so close. Look how close we were. This is the calculator doing a whole bunch of fancy equations and doing the residuals and finding out exactly how far away it is and all that kind of stuff, and doing all of that work, and it comes up with negative 42.3x plus 953. We came up with something almost exactly the same, negative 43.75x plus 956. We did a pretty good job by hand, if I do say so myself, and I do. So anyway, one thing I do want to show you that I ignored when we did this before, so we go calc lin reg. Note that there's a quad reg. That's the quadratic, if you know that it's a quadratic. There's other types of functions down there as well. In this class, we're just going to worry about the linear regression and the quadratic regression. So this one's still linear, so we did that and push enter. Notice that it gives you the r value right here, which is negative 0.96. All right, so their r value is negative 0.96, and of course I did forget my negative earlier, I apologize. So r was negative 0.9, and that's pretty close. We were off only by about 0.06, which is close enough. All right, and we got the r value right there, which was the next thing. Now it says make a prediction. There's two kind of predictions that you can make. One of them is an interpolation. Interpolation. Okay, and interpolation is inside your data points, right? So something, for example, we could say that would be if you choose a point that's inside of your line here, right? And you just choose a point and say, well, at this year there are this many million sales, right? That would be, for example, if you had missed a year in between and you wanted to know about how many years were sold, you could very easily look at something in between. Or if you were doing a census, which was every 5 years or 10 years or something like that. Okay, the other type of prediction that we can make is an extrapolation. And an extrapolation is extra. It's on the outside. So we could say, okay, well, it's now, this is now the year 2014, which someday I'm gonna look back at this video and say, wow, I made that back in 2014. That was like 3 years ago or something. But anyway, so if we want to do that, then what we could do is say, well, 6 was 2005, 7 was 2006, 2005, 6, 7, 2007, 2008, 2009, 2010, 2011, 2012, 2014. So in 2014, my x value would be 14, so we can just put it into the equation. So we say how many CDs are sold, that's the y, about how many would be sold in that year. Okay? And just work it out. And so we go negative 42.3 times 14 plus 953, was it? Yeah, 953. You push enter, and we predict that in 2014 there will be 300, what was it, 360? Yeah, 361 million CDs sold. Okay, so that would be an extrapolation. Now, interpolations are much better than extrapolations. Extrapolations, we assume that everything stays the way that it is and that the trend continues. Sometimes that's a good guess, sometimes it's not. You're always going to have people that just like to have CDs. They would prefer to have CDs than do their music electronically. So, you know, you got to deal with that, and you have to understand that fact that sometimes extrapolations may not be correct because something different may happen down the line. You know, if you went back several years before, you know, iTunes and all that, you would see that the number of CDs maybe even were going up, and after some point it started going down because iTunes popped up and Amazon popped up and all these things popped up that are selling music. So you just have to be careful. Extrapolations are iffy. You can do it. You can make that prediction that in 2014 360 million CDs will be sold, but at the same time, if possible, interpolations are much, much better in general. Okay, so that's the example. We've done everything on there. We've done each of the calculations by hand and by calculator, and I showed you a little bit extra on the calculator as well to check your averages. All right, so there you go, and we're done.